Good afternoon, sports fans. Well, the weather, it is chucking it down, and it has been for a number of hours now. Right, proper chucking it. Now, look, if you see those planets that are hanging up, there's Jupiter. That's not a ball on the grass, it's a planet hanging up. I have them all. There's Mars. Venus fell off and Mercury scooted itself all the way down to Earth. That kind of thing happened. So I had to kind of give the practical up. So I'm going to go over the classroom work first because it's extremely relevant. I have done this before and quite a few times, and a lot of people just could not get their heads around this, right? Now let's go over this. Right. This is about the time it takes the sun to radiate its light to planet Earth. 8 minutes and 20 seconds. Start at the very beginning. The sun, with a diameter of 1,390,000 kilometers, allegedly. Flat earthers, bear with me. I have to do it in the round scenario, okay? If we divide the sun's diameter by the speed of light, we get the number 4.6, and it's seconds. It's taking the sun 4.6 seconds to radiate its own light the distance of its own diameter. This is where the alarm bell should be ringing right now. The sun's diameter is about there, with a diameter of 1,390,000 kilometers, speed of light 299,792. It takes 1, 2, 3, 4.6 seconds for the sun to radiate its light the distance of its diameter. I think people should be going, what? But you're not. I think it's normal for a star. Anyway, now the distance between the sun and Earth is allegedly 150 million kilometers. If we divide the distance of 150 million kilometers by the sun's diameter, which is 1,390,000 kilometers, we get the number 100. It's 107.9. We're calling it 108. There are 108 sun diameters in between the sun and Earth. 8 minutes and 20 seconds. 8 minutes and 20 seconds. 4.6 seconds to radiate its light one diameter. 4.6 seconds per diameter. If we multiply that by 108, we get 500 seconds. Well, I think it's 498, but it's 8 minutes and 20. It's 500 seconds. The reason it takes light 8 minutes and 20 seconds to reach Earth from the sun is because the sun is radiating its light at a rate of one of its diameters every 4.6 seconds. There are 108 sun diameters. If we multiply that by the 4.6 seconds, there's your 500 seconds. There is your 8 minutes and 20 seconds. Can you imagine a bulb, a light bulb, taking 3, 2, 1, go. 1, 2, 3, 4.6 seconds to radiate its light the distance of its diameter. Folks, when I say it's about common sense, I mean it. Nothing takes 4.6 seconds to radiate anything its diameter. Even if you put an ice cube in the hot sun on the sidewalk, on the pavement, in the summer, that would maybe take 4.6 seconds to melt the distance of its diameter. That's how slow we're talking. Can you not see this? This is how slow we're talking. That bulb, how long would it take to radiate its light, the distance of its diameter? Bang! You can't measure it. Why don't you think the sun is doing the same as it gets bigger and bigger and more powerful? A powerhouse. Boom, the sun. But go. 1, 2. The light bulb. Pew! I'm talking diameters. The bigger a light source gets, the slower it radiates its light in relation to a smaller version of itself. That's what's happening. Think about it, right? It's wrong. I'm going to come back. I have all of that garden set out, and I'm going to be using a bulb that has a diameter of 8 millimeters. Eight millimeters, right? With a light bulb with a diameter, with a sun with a diameter of 8 millimeters, the distance to Earth, I've gone over it, is 86.4. .4 centimeters. An 8 millimeter light bulb for a sun, and they're actually on this board. You just can't see them. There's the sun. And there's Earth. Earth would be a speck. Nothing. A speck of dust. Tiny, tiny. Irrelevant. Alright, what we are interested in is the amount of time it would take that star to radiate its light. 86.4. Earth, from sun to Earth. So if we made a scale model and we brought it down, but to scale, everything proportionally correct, and we used an 8 millimeter sun, and we made a diagram, a model of the solar system using an 8 millimeter sun, a model of the solar system, everything broken down, the sun being the number one, everything revolving around the sun. It would take, in that model, if we were watching it in real life, the model, it would take 8 minutes and 20 seconds for the sun, that 8 millimeter light bulb, it would take it 8 minutes and 20 seconds. Because everything is to scale, including the way light behaves. Has to be. You can't have the light travelling at the speed light travels here, right? If I use an 8 millimeter bulb, look, it's instant, isn't it? But we don't want that. That's not why we're doing it. We want a to-scale diagram, and we want light to behave as it does up there. Everything the same ratio, proportionally the same, including the light that radiates from the sun. from the 8mm bulb. So what we need is an 8mm bulb that radiates its light at a rate of one of its diameters every 4.6 seconds, because that is what the sun does. Even though it's ever so big, that's what people's excuse for it. Yeah, but it's massive. Yeah, I know. And it's slowed right down. In relation to, it's ridiculous. Oh, where do I find a light bulb? An 8mm, any bulb, anything, in fact, anything that takes 4.6 seconds to radiate the light the distance of its diameter, because that's what the sun does. 1, 2, 3, 4.6. On your marks, get set, go. 1, 2, 3, 4. Look, it's ridiculous. It's ridiculous. I will come back, hopefully the weather will ease off, and we will do the nighttime practical. I was going to do it during the day first, but that's now out of the window. I have got, I'm going to call it an 8mm bulb, but it's really only 2 to 3, right? Now, if I have got an 8mm bulb and its light would travel proportionally the same as our star, the sun, right? At 1,390,000 kilometers, it would take this 8mm bulb, if it traveled at the same rate that the sun travels, and we know that the sun travels at a rate, the sun's light travels at a rate of one of its diameters every 4.6 seconds. It's ridiculous. So what we want is this bulb here to behave like the sun. Oh, that's a little bit faster, isn't it, than one of its diameters, considering that, see that mirror down there? That's where Pluto is, all to scale with an 8mm bulb. This is a 2-scale diagram of the solar system. And there comes my boy. Hey mate. All right, I will come back after, hopefully when the weather cools a bit. Yeah, it's all right, mate. And he's just had a haircut. And we will go over the numbers, because I assure you, anything taking 4.6 seconds to radiate its own light, the distance of its own diameter, is an insult to people's intelligence. All right, see you after.